We're going to look at some Pythagorean identity proofs. Be patient with yourself as you learn them, you'll get them. The first thing that we're going to do is come up with the equations, and then we're going to use them to solve some problems. We can come up with the first identity by the Pythagorean theorem from the unit circle. So if you remember from the unit circle, cosine is x, sine is y, and then the hypotenuse or radius is always 1. So if you do the Pythagorean theorem, sine squared x plus cosine squared x equals 1. That's where that first one comes from. And if you know that one, it's easy to memorize the other two because all you need to do is divide everything by sine squared, and you get this equation, and then divide everything by cosine squared, and you get this equation. So if you have to memorize all three, I would just memorize the first one and then quickly come up with the other two. Now we're going to look at an example. If you remember in the last video, we tried to change everything to sines and cosines. In this example, we're not going to be able to do that because they are sine and cosine already. But really good indicators of when you should do a Pythagorean identity is if you see two things that are squared or something squared with a 1 next to it. So if you look at this example, we have two things that are squared. I would underline those two things that are squared because we're going to try to replace those. We're going to try substituting something in. So look at your three Pythagorean identities and see which one has a sine squared and a cosine squared. So we have these two, or this one. This is the one that has a sine squared and a cosine squared. So I'm going to write that off to the side. In our proofs, we're not allowed to move things from the left and right, but in our side work we can. We don't need to here because this already equals exactly what we have in the problem that we underlined. So instead of sine squared plus cosine squared, we can just plug in a 1. We can substitute a 1. So now we have 1 over cosine, which is secant. The next example, we see something squared in the denominator, but in the numerator we have a squared and a 1. So this is where we should do our Pythagorean substitution. Let's look back at our identities. The one that has a cotangent squared is this top one. 1 plus cotangent squared equals cosecant squared. So this is just side work. It matches what we already have. Both of them are a 1 plus cotangent squared. So instead of what we have in the problem, we can substitute a cosecant squared x in. And that's going to make our solving easier because now it's the same thing over the same thing, so they cancel and we get 1.